We're going to get started in just a second, but I would suggest that if you have a notebook, something to write with, and a calculator, those can all come in handy. We're going to use our calculator a lot because we can, because we have it. So we'll use that and help take some of the mental energy you might use on doing the actual algorithms and the math and allow our calculator to do the hard work for us. So we're ready to go. So while you are just making sure you're ready, I'm going to start sharing my screen. So this first slide, I just have a few tips because while we're working with fractions, percents, ratios, a lot of the time we're going to be working with word problems. So some of these strategies may look familiar if you were in the last session. So just a few things to keep in mind. You really want to read the question thoroughly. You'll notice that when I go through and read questions, especially a little long, lengthier word problems, I'll underline, I'll circle, I'll highlight, just to really pull out some important information. You also want to just ask yourself when you get done, does my answer make sense, right? So if we start to really understand fractions, percents, and ratios as we go through some of these problems, we want to just make sure we are getting to an answer that makes sense to us. And then on that same note, you want to also make sure you're answering the question that is asked, right? So go back once you get a solution, double check that question before you mark your answer. And then you can just double check that you're not making a silly mistake after you did all the hard work. And then last tip, just specific for this topic, is that when it's appropriate, it might be easier to convert from a decimal or a fraction or a percent, you know, go through, we'll kind of talk about that today, just how to like transition smoothly through those three things. It can be really helpful at times if we're dealing with fractions, but all of our answers are in decimals. Let's just turn that fraction into a decimal and work that way. It might make the problem easier. So I'll go through and show you a few examples of that. And again, that's one of those things that if I say something and I say it too quickly or you want me to repeat it, please put something in the chat so that I make sure you guys really get that, because I think that's one of the most important things that we can do on this topic. So again, this will all be accessible to you. So if anything you want to come back and revisit, you'll be able to see the video. But I'm going to jump into our first question. Okay, and just maybe zoom in just a tad. I should be able to see that all right. So the first question just says the number 22 is what percent of 54? Okay, so this is our first question, and this is one of those things where I'm going to go through and I'm just going to make sure I know what I'm trying to find. And in this case, we want to find the percent. So I put a little, I'll just make that a little smaller. I put a little proportion down here or a ratio that I find to be really helpful when I'm talking about percents. So there's a bunch of different ways to do this, but if this is something that you know you struggle with, right here, this might be something that's really helpful. So I'm going to set it up like this, and then if you have another way, or if maybe I'll show you another way after that too, if that feels good. So the first thing that we want to do is we want to plug in what we know. So the percent is what I don't know. I underlined that, right? So I'm just going to give it a variable, just a little placeholder. I'll just give it an X, right? And then over 100, that never changes because a percent literally just means out of 100. Okay, and bear with me as I try to draw on a laptop. It's not so easy. So then we have the part over the whole. So then this is the question of, well, what is the part and what's the whole? So the number 22 is what percent of 54. 22 is the part, and then 54 is the whole. And then we just have a little equation that we need to solve. So I'll give you guys a second to see if you think you know how you might solve it. But this, again, setting it up like this can be a really helpful way to then have a game plan and tackle the question. I'm just going to extend my page. And those of you that are just jumping right into it, you might have a few different ways to do this. But for me, I might just, this might remind you of algebra cross multiply. Okay, and this is a great opportunity where we may be using our calculators. We may need to just say, okay, well, I know I have to do 22 times 100. Plug that right in. So I get 2,200, and that's going to equal 54x. And then I just need to divide by 54 and get x by itself. And when I do this, I get this pretty long repeating decimal. I'm just going to put it to a couple decimal places so you can see what we get. Okay, so cross multiplied and then had to divide by that 54. And now we just have to go and choose the answer that looks best. So sometimes with these questions, we aren't given the exact answer here. We then have to just choose the one that is the closest. And in this case, that would have to be 41%. So our solution here would be 41%. Okay, so like I said, definitely a few other ways to solve it, but that is one strategy that may be helpful if percents are not your favorite.
Yeah, and it looks like everybody on here has 41%, so
awesome.
Everybody's doing a good job on that.
Perfect. Cool. All right, let's move along. Now we got a word problem, so let me zoom in a little bit again, make sure we can all see this. So it says, if a survey finds that 120 people are in group X, okay, and 230 people are in group Y, what is the ratio of people in group Y to people in group X or Y or group Y? Okay, so like a lot going on here. The fact that I see the word ratio, I'm going to highlight that for us real quick. This is really important to note that when we see the word ratio, the way we do the order of that ratio is super important. So all of these ratios have the little semicolon, so we can set it up like that, just so we have the consistency and we'll know when we get the right answer. So I know I have 120 people in group X, and sometimes I just like to take my information and bring it down here in group X. And then what's it say? 230 people in group Y. And I have to find the ratio of people in group Y to, and that semicolon is what we use for to, group X or Y. And then from there, I just have to plug in the numbers that I know. So group Y is 230. Oops. Group Y is 230. And then group X or Y, we will have to just add those together. So again, feel free, if you've got it mentally, go for it. If not, plug it in your calculator. 120 plus the 230 would give me 350. So again, like I said, order is super important here, okay? Because if we do it in the opposite order, we're not answering the question that is asked. So when I go to look at my solutions, I do not have the exact answer, but it looks like I just have to simplify. So in this case, a nice easy trick is seeing that they both have the 0 at the end. Basically, if I divide each by 10, I'll be able to get one of these answers, which looks right here to be what I'm looking for. The ratio would be 23 to 35. So just that last step would then be simplifying to get to 23 to 35. Okay. All right, so just knowing order is important for that one. And we will move along. So far we've done a percent and we've done a ratio.
And so there were 2 questions on that, Ashley. One person was asking, what would we simplify? And Delene Francois, I'm not sure if you can clarify that. Does that make sense, Ashley, or are you not sure what she meant by?
Yeah, what to simplify?
Yeah.
Cool. Yeah, exactly. So basically, it's interesting because a ratio, it can also be written as a fraction. So we're basically simplifying this in the same way we'd simplify a fraction, where if we have a factor, a number that can go into both of the numbers we see here, then we can simplify. And essentially, in this case, we're just dividing by 10. So when we divide by 10, we break it down to 23 to 35. So I'll just write that here, where at the step, if we divide each side by 10. So basically think about breaking down fractions, simplifying fractions. It's the same thing for ratios. So 230 divided by 10, yep, and then 350 divided by 10. And did you say there was a second question?
I don't think so. I think you answered it by going through that problem again.
Perfect. Okay, cool. Awesome. So that can also be one of the hardest parts of this, is knowing what to simplify. So this one happened to just be dividing by 10 fairly easily. But if it's another number that's a little harder, it's always good to look for 2s or 5s, you know, some of those easier numbers, and see if you can simplify. Or once you get this answer and you're just like, oh, wait, I don't know which one of these is equivalent, you can always work kind of backwards and go through each option and say, well, could I multiply 12 times something to get 230? And if so, could I multiply the same thing by 35 to get 350? So if that's a little bit sticky for you or a little bit rusty, you can always kind of work backwards to make sure you're getting to the same solution. All right, so let's move on to our next question. It says, if a tree grows an average of 4.2 inches a day, what is the rate of change in its height per month? Okay, and we're assuming a month is 30 days. So again, I'm just gonna jot down the information we have, 4.2 inches a day. And then what we need to know is the rate of change in its height per month. Okay, we want to know the change in its height per month. So again, we know that there are 30 days. So we basically just have to do the 4.2 inches that happens every day and then multiply that by 30. And that will tell us how much it's changed. So 4.2 times 30, I can just plug that right in my calculator and get 126. Okay, so our solution would be 126 inches per month. Oops, that's not the right one, sorry. 126 inches per month, okay?
Perfect. And you would be surprised, Ashley, 126 was popping up on the chat like way before you even got to solving that problem. So
perfect.
People are saying they're getting it now after kind of seeing that explanation.
Good, awesome. Yeah, and again, this is one of those questions where like the last part of the question really gives you kind of that help of like, well, what do I have to do here? Knowing that you have to know the height per month, knowing that 30 days in a month, that can really help you get there. So good, I'm so glad you guys are getting this. This one is a little bit different. So this might be a little bit of a shift, but again, keep doing what you're doing. If you're feeling good about it, send it in the chat. And if you want to just follow along, that is great too. So it says a college graduate takes their first employment check, $2,500, puts it in a retirement fund. Okay, if the 4.7% interest rate is always based upon that initial deposit amount, how much money will they have in the account after 20 years? Okay, so somebody deposits $2,500, okay? And they put it into a retirement fund at 4.7% interest, okay? And that it says that interest rate, this is such an interesting thing that it says here, is always based upon that initial deposit amount. So it sounds like we're not really adding anything else to it. Also doesn't sound like it's compound interest. It's only worried about this 2,500 that is getting the 4.7%. Okay, so how much money will they have after 20 years? A couple different ways to do this. The first thing that I thought of was I was curious, well, what interest are they getting every year? So that was where I started for this question. So super important that when we're dealing with percents in like algebraic equations, or if we're setting them up and putting them in our calculator, we have to turn it into a decimal, which might sound kind of weird because this already is a decimal, but 4.7% is the same thing as 0.047. Yes, 0.047. So we have to, whenever you have a percent and you want to turn it into a decimal, even if it has a decimal in it already, this is my little trick that I like to do. I just take the decimal and I swoop it twice. And then in this case, you see I have a little spot with nothing. I put that 0 placeholder and I've moved my decimal over here. So that's how I got to 0.047. So that's important, and that will help me figure out how much interest we are going to get per year. So I'm going to multiply that by the 2,500. And this tells me that this college graduate is getting $117.50 per year in interest. Okay, so again, I'm just going to revisit the question. How much money will they have in the account after 20 years? Okay, so I don't know how much they make in 20 years, but if I multiply this by 20, I can find how much interest they've made altogether. So again, just plugging this in my calculator, and I get, oops, 2,350. There's my equal sign. Okay, so this is a place to stop and make sure we're answering the question that's asked, right? So how much money will they have in the account? So nothing that I have here actually tells me how much they have in the account. All I have is the interest. So then I have to go back and I have to remember, oh yeah, they initially deposited this $2,500. So I have to combine those two. The initial principal, right? And then the interest, that'll give me my total. So 2,500 plus 2,350 would give me $4,850 in the account.
Awesome. And a lot of people had that, Ashlee. Can you
Perfect.
kind of reiterate how important it is to really understand what the question is asking and to not like jump off on, you set up your equation, you solved it, and you think you've got the answer. It happens to be one of the choices because maybe they were trying to throw you off, but that wasn't the question asked. So how important is that when you're kind of looking at these types of things and realizing that there's actually another step you need to take?
Yeah, I mean, honestly, that's one of the most important parts of tests like these and these type of questions, where you can know all of the, all the correct mathematical steps, but if you don't take that last second to ask yourself, am I answering the right question? Does my answer make sense? If you don't ask yourself those questions, and really it'll take like 2 seconds. Once you're doing this and you just ask yourself that, you'll either stop and say, wait, that doesn't sound right, or you'll be, yep, that looks good. And then, that extra just like pause will really help you increase your accuracy with these types of questions. So super important. And this is one where, like, I know a lot of people, easy mistake to make, would have stopped here. Luckily, that wasn't actually an answer. So we could have, at that point been like, oh, wait, I think I missed something, which is great. But sometimes they will put that as the solution. And if you go back and look, does that make sense? You're like, well, they need to have how much in their account? They initially put 2,500. They shouldn't have less, right? So that's where those questions can come in really handy. Yeah. In the meantime, I'm just going to bounce to the next question, because this is a really good one for us to kind of check in on how we're feeling about ratios, percents, all of that stuff, kind of all here. So
she typed her question, so we can
okay,
just,
great.
knock it out. But she says, so when trying to find the percent to multiply by, can you just divide by 100?
Absolutely. That's another perfect way to do that. And I will add that. That's awesome. Divide by 100. That's basically what my little trick does. So yeah, absolutely. And that's another thing. Use that calculator. 4.7 divided by 100 will get you to the same place. Awesome. Cool. Thanks for that. That's a good tip.
Cool.
Sweet. Okay. So again, here is a good one for you guys to try on your own. And this will kind of test a little bit of everything when it comes to percents, fractions, and ratios. So which is different from the others? You'll notice that we have a percent, a fraction, a ratio, and then the last option just says all of the above are equal. So I'm going to give you all a second just to think about it, and feel free to put your answer in the chat, and then we will go over this really quickly with a few different strategies. This is a great way for me to just give you a few different ways to convert between those percents, those fractions, those decimals, all of that. So go ahead and put your answer in the chat. I'll give you about 30 seconds just to think on it, and then I'll jump in.
So we've got some interesting answers coming in here. Most are going with D. Just about everybody is. So
A.
Perfect. So let's go over a few of these. So it says which is different from the others. So again, just a great chance to just stop and pause and make sure we're answering the right question, right? So either one of these is going to be different, or they're all going to be the same, and then we'll know what our answer is. So when I first looked at this question, I thought it would be a lot simpler to compare if they were all of the same type. They were all either percents or fractions or ratios. And for me, putting these all into fractions seemed like the easiest way to go. So I'm going to demonstrate that. And then if you had another strategy, feel free to hop in when I'm done. So for percent, we've been saying that a percent just means out of 100. So to take 6.4% and turn it into a fraction, all I have to do is take 6.4 and put it over 100. It's a little bit weird to have a decimal over, in the numerator of a fraction. So I'm then just going to convert it a little bit farther and basically multiply both the top and bottom by 10 to get rid of that decimal place here. So this is actually just the same thing as 64 over 1,000. Okay, so that was just how I decided to take the percent and turn it into a fraction. So I already have my 8 over 125. And then ratios can be written with the semicolon, or they can also be written as fractions. And again, the order is important. So the 128 comes first, and that is over 2,000. So I'll offer you 2 ways that you can, now that they're all fractions, you can check. Okay, really quick, easy way to do this is to use your calculator. And a fraction symbol really just means divide. So if I take each of these and just divide the top by the bottom, I will either find that there's one that's different or they're all the same. So 64 divided by 1,000, I'll just write this off to the side so that you see what I got for each one. So when I did this, I got 0.064. Okay, then when I do 8 divided by 125, okay, got 0.064. And last but not least, the 128 divided by 2,000, I again got 0.064. And that leads me to believe my answer has to be all of the above are equal. Okay, so this is a really nice trick to use when you're dealing with fractions. And this is a great way to convert from a fraction to a decimal, is just to divide. Take the top divided by the bottom, and then these are really nice and easy to see. Other strategy could be changing these back into equivalent fractions if you want. I think it's a little more work probably. This allows your calculator to just do the work for you. So I'll just type into what I did here, basically just divide the top by the bottom.
And I think that's always helpful to mention, Ashley, if one method is, can be quicker or shorter than the other, because these are timed tests, and for the most part, you have, depending on which test, but roughly it's something like 1 minute per question. So you need to be able to move through it pretty quick. And I know there's kind of definitely different ways to do it, but I think as you're going through, if there's, if it ever comes to mind, if there's faster ways or slower ways, different ways to do it, but one might be faster, that's always helpful info.
Perfect. Yeah, I would definitely say that this is the faster way to do that. So we'll stick with that one for the time being. Yeah, and I just think putting it into a fraction first, if that's something that you see off the bat, that's a really easy way. Then we just use the calculator to divide. If you could kind of skip this step and just put them all into decimals, or however you saw that, whatever is quickest for you works. This is a strategy that is something that can work if you didn't see it right away. Okay. Any questions for that one? Anything to go over? All right, we will move along. We've got a few more questions. All right, a farmer lost 60 of his 1,200 tomatoes for his harvest due to poor maintenance. If he lost 75 corn and lost the same percentage of his corn as his tomatoes, how many corn was he originally expected to harvest? Okay, so I know this is what I'm gonna have to answer. Okay, so there's a little bit of information that I don't know here, and there's a couple different ways to do it. I'll show you again the way that I think is the quickest. So basically what I would do, if I know that they have to have the same percentage, that's basically saying that the ratio of the tomatoes that the farmer lost to his total tomatoes has to be the same as the corn he lost to his total corn. So setting up a quick ratio is probably going to be the easiest way to do this. So I'm going to put the 60 tomatoes that he lost over the 1,200 that he originally had, okay? And then, because we know that has to be the same percentage, I'm gonna set that equal to the 75 corn that he lost. And then the question is, how many was he originally expecting to harvest? Okay, that's the total, okay? So I'm just gonna put an X at the bottom. Okay, so for this question, setting it up like this, the main thing to really notice is that you're putting, you're keeping consistency with, like, this is the lost corn, or the lost tomato, sorry, over the total. This is the ones that he lost over the total. So important to keep it like that. Okay, and from this step, again, can be strategy to cross multiply like that. So I will just use my calculator I'm going to have 60 times that x, that mystery number, and then do 75 times 1,200. Okay, and then again, just to get x by itself, I will divide that 90,000 by 60, and I get 1,500. Okay, so again, I can just ask myself, does that make sense? Okay, how many corn was he originally expecting to harvest? 1,500. That does sound reasonable comparatively to the tomatoes. So I feel like I'm answering the question that's asked, and there we go. Okay, so setting up the ratio there is just kind of a way to do it pretty much in one step, 1 or 2 steps.
Cool, sounds good. Everybody had the correct
Looks
answer
good.
for that one.
Perfect. Okay. Move along. This is another one that might be good for you to kind of just test how you feel about all the ratios and percents and just kind of converting back and forth. So it says, what is the product of 5 to 2? That's our ratio, 5 to 2, and 65%. So important to know what this word means, right? Product means multiply. So basically what we're going to have to do is we're going to have to do 5 to 2, and we're going to have to multiply that by 65%. Okay, and then I noticed that the answers, sometimes it's really nice to look at our solutions before we go doing all the work. I noticed they're all in fractions. So that may guide the way that I convert these to be of the same type. For me, I just find that to be so much easier. So in this case, I'm going to convert them into fractions. It looks like it should be fairly easy to do. So 5 to 2 can just be written as 5 over 2, right? The order is definitely important. Doesn't matter that the bigger number's on top, that is fine. And then we need to multiply this by 65% again, right? Means 65, oops, that's a 6. 65 over 100. Okay, so multiplying fractions, a little reminder here, you just go across the top and across the bottom. So to multiply fractions, go across the top and across the bottom. So what I mean by that is just multiply the top numbers times the top numbers and the bottom numbers times the bottom numbers. Okay. And again, I'm going to show you a little trick here. Let me just change my color real quick because this is a strategy I love to use when I am multiplying fractions, especially because I'm probably going to need to simplify by looking at my solution. So even if you think you know how to do this, just stay with me for a moment and we're going to try to see essentially if we can simplify before we multiply. Okay, simplify before we multiply. So the way to do that is to look at the top numbers and the bottom numbers and see, basically you're asking yourself, is there something, a factor that goes into one of these top numbers that also goes into the bottom numbers? Okay, so there's a bunch of different ways to do this. Just the first one that pops out to me is the 5. If I divide this by 5, I would get 1. And if I do it on the top, I have to do it on the bottom. So I'm going to divide this one by 5, and I get 20. Okay, so once I've simplified that, that can be a little bit easier. And there might be more to do. I actually, I could do this again and see 65. I know that's divisible by 5. So if I break that down, 65 divided by 5 is 13. But again, if I do it on the top, I also need to do it on the bottom. And 20 is divisible by 5 again, so I could get 4. So this is just a little trick that can help you simplify before you go and multiply and have really big numbers. Okay, so once I go through and do this, now I just have to go 1 times 13, which is just 13, right? And then 2 times the 4, that's all I had left over after I divided by 5 a couple times. And that's 8. So 13 over 8. If I look at my options, that's not a solution, but I just have to convert it into a, oops, sorry about that. Just have to convert this into a mixed number. And I know that 8 goes into 13 one time, and that would leave me with 5 left over. So 1 5/8 would be my solution. So again, what I did here, this is called cross-canceling. I basically just divided something on the top by a factor, did the same thing on the bottom. And then I just happened to be able to do it twice, and that got me to not be able to, or to not have to simplify at the end. So it makes it a little bit easier. Please feel free to hop in if any of what I just said was confusing, and I can give you another example of that. But I think that's super helpful. Cool. Okay, awesome. So we will move along then. That is a great just strategy to have in your toolbox. So, you know, when you're going and multiplying fractions, you might use that. So here we got some more fractions here. So I'll try to zoom in a little bit more so we could see better.
Cool.
Awesome. Okay, so a baker uses 4/5 of a bag of chocolate chips to make cookies for the day. She does this for another 3 days in a row. On the 5th day, she uses only 1/2 a bag. So the question is, how many bags did the baker use during these 5 days? Okay, so we are going to be dealing with fractions here. The wording in this is a little bit tricky, so don't get fooled by this over here. She does this for another 3 days in a row. So she didn't do this for 3 days. She did it for 4 total days of the 4/5. And then on the last day, on the 5th day, she only used 1/2. Okay, so a couple different ways that you could do this. You could either do repeated addition and just add all these things together. I'm going to just simplify this process a little bit. Again, this is just a quicker strategy, and I'm going to multiply the 4 times the 4/5. Okay, I'm going to multiply that because I know this happened 4 times, and if I just multiply, it'll be a little bit simpler. So going across the top, you do 4 times 4, which is 16, and then you would keep that denominator. So 16/5 is what she used on those first 4 days, right? And then we have to go through and we have to add in that 5th day. So 16/5 plus the 1/2. Okay, so right here, we're adding fractions with unlike denominators. So we have to get a common denominator before we can actually move forward. Okay, so 5 and 2, pretty easy numbers to work with. What I would probably just do is I would just do 5 times 2, and I would want to convert these each into something with a denominator of 10. Okay, so just I'll just give you a quick reminder of how to do that. If I need to go from 16/5 to something over 10, okay, to get from 5 on the bottom to be 10, I have to multiply this by 2. Okay, so again, I'm saying this for like the 4th time. It's super important. With fractions, if you do something on the top, you have to do it on the bottom. And likewise, if you do it on the bottom, you have to do it on the top. So I multiplied 5 by 2 to get 10, so I have to do 16 times 2 in order to keep that equivalent fraction. Okay, so just a quick little reminder of that. Likewise, with 1/2, you probably could see this pretty quickly, but just to reiterate, I would have to do 2 times 5 to get 10, and if I do it on the bottom, in this case, I have to do it on the top. Okay, so I'm going to get 32, oops, that's a 5. 32 tenths plus 5 tenths, and if I go through and add these together, I will end up getting, all I have to do is add the top, 32 plus 5 is 37, and keep the bottom, 37 tenths. So if I go back and look at my answers, I don't see that one, but I do see that these are all mixed numbers, so I just have to go back and convert to a mixed number. So 37 over 10, we get 10 goes into 37 3 times with 7 left over. So 3 and 7 tenths, which I see as our last choice here, would be our solution. Okay, so adding fractions with unlike denominators, just don't forget to make sure you have a common denominator, and then you can just go through and add, and last step was to convert it into a mixed number.
So someone was saying they were confused on how do you convert?
From one of these improper fractions to a mixed number, that, or the common denominator, or both?
I think we were trying to clarify for it. She said yes to the first thing you said, I think. Improper fraction to mix. The improper fraction to mix, yeah.
Awesome. Okay, so basically, if we have, like this is our improper fraction, 37 over 10. This may sound silly, but I can't ever think of it any other way. I always just think about it as if this were like a candy bar, right? And this bottom part is telling me, okay, well, it's cut into 10 pieces. So if I had a candy bar, let's cut into 10 pieces. 10 pieces makes 1, okay? So 20 pieces would make 2, 30 would make 3, 40 would make 4. So I don't have quite 40. So the only thing that I could do is I can make 3 whole candy bars. So basically I'm doing 37 divided by 10. And I know that it can only actually come out, 10 can only come out 3 times. And then 10 times 3 was 30. So 37 divided by that 30 that I already used leaves me the 7 here, okay? And then it stays over that same denominator. So here, I'll just type this quick little step out. So basically you find how many times the bottom goes into the top, okay? And that's gonna give you your whole number. Okay, that's gonna give you that whole number. And then whatever you have left over, that's gonna be your numerator, okay? So whatever you have left over will be your numerator. I hope that is more clear. Oops. Okay, just so that's clear and people will see it in the future. Awesome, good question. So we are just looking at the clock. I want to double check and see if there's any specific ones that I do. Yeah, I do want to go over this one. So I'm going to just skip this question real quick. I will zoom in if this is one that you wanted to practice. You can feel free to come back to this video at a different time and see if you can get this as your solution. Okay, and then I'm going to bounce to the next question because I think the next one is more important for us to make sure we have time for. Okay, so 3 friends go into a sandwich shop and purchase the famous 3-foot-long hoagie sandwich. The friends overestimated how hungry they were. One friend ate 1/6 of the sandwich, while the other 2 friends had 1/4 each. How much of the sandwich remains? So my question is going to be finding out how much is left over. Okay, so this is another one where I really like to look and see what are my options. And I notice that all of my options are in inches, which my 3-foot-long hoagie is not in inches, but I can turn it into inches fairly quickly. So for me, that's just something that I'm gonna note. I don't know if I'll necessarily need it, but it feels like it might be important. So the 3-foot-long sandwich, so if 1 foot is 12 inches, 3 times 12, that will give me 36 total inches that they have to eat. Right? So I think that might be important, but we'll see. So how much of the sandwich remains? Because I've already done this, I think probably the quickest way to go about this is to find the fractional part of the sandwich in inches that they already ate. That might be a little bit easier of a way to do this. So 1/6 of 36, okay? 1/6 of 36, that's what the first friend ate. I just have to do 36 divided by 6, and I'll find that they ate 6 inches. Okay, the 1/4 of 36, again, just what's 36 divided by 4, and we will get 9 inches. Okay, and that's not just, that didn't just happen once, right? That happened for another friend too. So that's what we've got so far that was eaten. So I'm just going to go through and add it up real quick. So 6 plus 9 plus 9 gives me 24 total inches. So I know that they ate 24 inches. And if in that case, 36 minus the 24 that they ate, this is again where it comes in really important to look, what is the question asking? How much remains? So 36 minus the 24 that they ate would leave me with 12 remaining. Okay, so I think this is the quickest way to go about solving this question. Probably could have used fractions and gone through and worked that way and, you know, adding fractions and all that, but then we'd have to combine, or we'd have to find a common denominator, and this way we didn't have to. So a great strategy here was looking at the question, looking at the answers of the question to figure out, oh, if I convert, this might be a little bit easier. So that's just a little tip there. Okay, and then one more question I definitely want to make sure we get to is, I think this one. Yeah, okay. So for those of you who fractions don't happen to be your best friend, this might just be a good thing to practice before we run out of time today. So all this says is divide, and hopefully now that I've zoomed in, you can see it a little bit better. 1 and 9/14 divided by 3/5. This is one of those questions that the quickest way to do it is just to remember the process for dividing fractions and use your calculator to help you where you can, but there isn't really like a shortcut, unfortunately. So I'm just gonna go through and I'm gonna rewrite this down here. 1 and 9/14 divided by 3/5. And I like to use the acronym KCF to remember what to do when dividing fractions. So I don't know if this will bring you back to like middle school or something, but this is how I learned how to do it, and it's always stuck with me. Kind of like KFC, but not quite, right? KCF. So what this means is keep, change, flip. Okay, so basically what we do when we use KCF to divide is we keep the first one. We don't have to change that one at all. That one stays the same. So 1 and 9/14. Okay, and then I change my division symbol to multiplication. And then I flip from 3/5 and I just flip-flop those places to 5/3. Okay, keep, change, flip. So now I go through the process of, excuse me, multiplying fractions. For me, I like to get rid of this mixed number here and turn this into an improper fraction, so I can do the process of just going across the top and across the bottom. So here's a quick reminder of how to do that. You just do 14 times 1, which happens to be 14. And then you add the top number. So 14 plus 9 would be 23. So basically what we have is 23 over 14 times, sorry about that, times 5/3. Okay, so take a second and just, if you haven't already, go ahead and multiply across the top and across the bottom. And once you get your answer, check and see if it's one of the solutions. And if not, then we might have to convert a little further. So I'll give you a second, make sure you wrote that down, and then I'll go back and look at the answer so you can decide which one you think is correct. So again, just multiply across the top, 23 times 5, across the bottom, 14 times 3. So I believe you should get 115 over 42, which is lovely, but I unfortunately don't see that up here. So 115 over 42, okay? This is where, again, we can just convert it into a mixed number by asking ourselves, okay, how many times does 42 go into 115? These numbers aren't so simple to work with, so I might just use my calculator and plug in 115 divided by 42. And I get 2 and some change, right? 2 and a decimal. So I know it only goes in twice, and then I'll have some left over. So I'll be 2, and then 42 times 2 was 84. So 115 minus the 84 would leave me with 31 left over. Okay, so 31 over 42. And this is also one where once you've gotten to this step, okay, you might be able to use process of elimination to get your answer. And once we knew that we had a 2 in front, this was the only one that would make sense. Okay, so keep, change, flip is a great strategy for dividing fractions. If you have another strategy that works for you, go for it. But here's one to add to your toolbox if you are not a fan of dividing fractions.
All right, so the thank yous are flooding in. You can see it on the chat.
Yes,
if you
thank you all.
If you want to feel good about yourself. Cool.
Oh, Karen,
So,
good luck. Your test is on Tuesday. Good luck.
Oh, Ashlee's the GOAT, somebody said. What? Okay, cool. All right, sounds good. So we appreciate the time, Ashlee. We'll see you again tomorrow. And then for anybody else who wants to hang on for a few minutes, if you want to check out the online course, if you don't, have it already, I'm going to do a quick walkthrough of it so you can check it out. And we'll go ahead and let Ashlee go. So we appreciate the time, Ashlee. We'll see you. And then anybody else who wants to hang in, I'm going to share my screen. I'm just going to give a quick walkthrough of the online course and kind of some ways you can use it to help you pass the test. So I'll go ahead and do that in just a second here. So I have the TEAS course pulled up. Throw in the chat too if you're still on here. If you were taking the TEAS, the HESI, or the Kaplan test, I will kind of walk through the TEAS online course. As far as what it looks and feels like, it's exactly the same for the HESI or the Kaplan. The only difference is once I get into kind of the actual course content, it's going to be a little bit different depending on those tests. So, you know, HESI, for example, there's a physics section. There's not physics on TEAS or Kaplan, so you wouldn't see that in that course. But the way that this looks and feels and the way that you move through this course is going to be exactly the same, regardless of which course you have. So as I go through this course, you know, we do point out the Facebook study group here. If anybody is not in the Facebook study group, let me know and we can drop that link in the chat so that you can join that. There's, you know, each group has a couple thousand people in it that all kind of help each other out, answer questions, help share good resources and things like that. So I would highly recommend joining the Facebook study groups if you are not in them now. So what the course is composed of is it's going to be lesson modules for every topic on the test. So if I'm in the reading section, you'd have a couple of different parts to the reading section, and every single topic that's on the test will be covered here in a lesson module for math, science, English reading for the TEAS. And I'm just going to go into one of these lessons. I think I'll go to the cardiovascular system. And each of these lessons are composed of video lessons. You'll have all your content and your material that you can read, but if you want to more of a visual learner, you can read or rather listen and watch the videos. So the cardiovascular system, there's actually 2 videos for this lesson, and these are about like 10 minutes, I think.
Welcome to
about 11 minutes, and something similar here, 12 minutes. They average about 5 to 15 minutes, and they kind of do a dive into each of these topics and kind of just give you a different way to learn in addition to the actual material down here. So you can watch that video lesson, and then we can go through the lesson, and it'll kind of have all the different parts of that topic, everything you need to know to become familiar and competent in each of these topics. You have questions kind of built in throughout. So it's kind of testing you on what you just studied. And as you go through, so as we go through this, we also make it a point to not just have multiple choice questions. Now, all of these tests, the TEAS, HESI, Kaplan, they're all multiple choice questions, but it's not always the best way to learn. So in addition to kind of lots of images and illustrations and things like that, you get questions like this that are kind of place each event in the order that they occur. And so that you would have to drag this around and order them correctly. And of course, you just learn this with the material above. And then you can see that you got that wrong, and it'll explain to you the correct order of events. So there's things like that, or just fill in the blanks. Things where you have to kind of mix and match stuff. So again, your actual test is going to be multiple choice, but it really helps to kind of test your own memory, what you just learned, that kind of repetition to, you know, exercise your brain on what you just learned, do some of these things while you're actually in the lesson is definitely helpful. So you get a lot of stuff like this in each of the lessons. Again, label in the EKG chart, things like that. More labeling the heart in the correct order. So all kinds of more interactive things. And again, this is one of the differences between the study guide book and the online course is you just can't have this type of thing in a study guide book. So the study guide book is a great resource, but the online course has things that you just can't do. And another thing that the online course has that really you can't do with the book is it has really in-depth answer explanations. And if you, I'll show those in just a second, but if you put these in-depth answer explanations in the book, it would be like a 1,000-page book. So you kind of just can't do that. So it's kind of one of the differences. And then at the end of each lesson, you'll have flashcards. So you can take these flashcards, you can mark them if you got them right or wrong. If you mark them right, it'll take it out of the deck so that you will just be working with the ones you're getting wrong. And if you refresh this page, it'll restart this and you can kind of work through this, this deck again. So that's the cardiovascular lesson. So you can navigate through the course here. And there's other cool stuff like, you know, a dark mode and things like that, you know, depending on how you like to learn, maybe the time of day, things like that. So I'm going to go over, you know, that was a lesson to look at. So the next thing we can look at is the actual practice tests themselves. So I'll go into one of these practice tests, and these are timed practice tests, and they're the exact number of questions, very similar questions in the topics that they're asking about, the way that they're asking about them, the difficulty of the questions. They're all meant to be very aligned to the actual test. So a couple things for the practice test. Once I start the practice test, it's going to start the timer. And these practice tests are so helpful for you guys because this test, at least the TEAS and really the Kaplan and HESI are, I think the HESI is even longer, but the TEAS is 3.5 hours long. So you don't want to go in on your test day and have it be the first time that you've had to sit for 3.5 hours continuously. You want to have done that a couple of times so that you're kind of exercising your brain. It's like running a marathon. You wouldn't just show up on the marathon day. Yesterday you practiced running 4 miles and now you're going to run 26 miles. You want to be really getting as close to you can as, you know, the actual length of the test. And what can happen for a lot of people, if they're not doing that, they get into their last section and their brain is fried, they're burnt, they're not kind of used to it and ready for it. And the whole second half of that section can be a total waste because, you know, you're just not used to doing a 3.5 hour test. So that's the test itself. And then of course, each section is important that it's timed because you need to be able to answer these questions within the allotted time frame. And this becomes really important with all the different subjects, but you know, particularly things like reading, the reading section. The passages are really long, and you need to be able to read those passages, see the questions, go back to the passage, find the answer, pull that out, answer the question, move on to the next question. And you need to be able to do that very quickly. So working within these time limits over and over again on these practice tests is really how you get good at doing that. Another example is like word problems for math. A lot of times, you know, you have like 1 minute to answer that word problem. And some people will sit there for 4 minutes trying to answer a word problem. You just can't do that. You're not going to be able to answer all the questions. So getting comfortable with these time limits is super, super important. And that's something I really can't stress enough. So I'm going to go ahead and just skip right to the end of this test, and I'll finish the test. And what it will give me is a scored report. Now, this scored report breaks down each and every question that was in that practice test by the topic that it covered within science. So you can see, I think I answered one of the questions. There was probably 3 questions for chemical solutions. I answered one of them correctly, I think. But you might see that you got 100% of the cardiovascular questions correct. You got none of the endocrine systems correct. You got 15% on the muscular system and 100% on the nervous system. So what this does is it gives you an idea of what your strengths and weaknesses are. And when you see that you scored really low after getting a couple of these different topic questions on the test, you get an idea of what your weaknesses are. And then you can use the rest of the course or any other resources you have to really focus on your weak areas. And that's the most efficient way to use your time. And it's what will help you bring your score up the fastest. So once I have that, I can click View Questions here, and it will bring up all the answer explanations. And as I explained, we, I don't know, about 3 or 4 months ago, went through and redid all the answer explanations to be much more in-depth. And as you can kind of see, like an answer explanation like this in the book is kind of not possible. So you have sort of a shorter version of that, but you really get the idea that the answer explanations, do a really good job in explaining kind of why answers are right or wrong, and include images and illustrations and things like that. So that is the practice test. The other thing that I'll show you is that you can go back to these practice tests and see what your results were. And under this statistics column, you can see, you know, what your score was, but under the statistics column, you'll get a detailed scored report. So I'll just pick one here, math test, and it'll bring up that whole test, and it organizes it kind of a little bit differently. It adds in the questions, so it'll tell you for the category addition and subtraction of fractions, you had 4 questions on this practice test. And this is how you did. These are the answers, or the incorrect and correct answers you got. And what's really cool is, you know, it doesn't show it here because I went through it real quick. Well, here's one where it shows me the exact time I spent on that question. So I spent 50 seconds answering this question. And again, this gets really important, particularly for math, because you need to be able to answer these questions very quickly, typically under a minute. So you can go through this and see, oh my gosh, I didn't realize while I was taking it, but I spent 2.5 minutes on this particular question. Or I noticed that every time I got equations with one variable, I was going way over, you know, how long I should have been spending. And then that is something that you can work on. You can kind of specifically focus to make sure that you're spending time trying to get faster and faster at those types of questions, right? And then, you know, down at the bottom, you get your total overall score. So that is kind of going back and looking at the test at a later date, if you want to go back and review that. So that's the practice tests. There's 8 practice tests. I actually put in a bonus practice test as well that is mostly all just chemistry and biology. We started hearing a lot of students saying that they were getting more chemistry than they expected. And just as a side note, the T7 is coming out next year, and the T7 has a lot less A&P in the science section and a lot more chemistry and biology. So there's a bonus test there. After the practice test, you have the question bank. I'm just going to go in through here, just a different view. And I'll go to the second page of the course. And you will have this question bank by topic. So, you know, you can do all the practice tests, and if you do the science practice test, it's going to mix in all the different topics, chemistry, biology, all the different A&P systems. But you might want to just focus on specifically word problems or specifically, you know, a particular A&P system. So we created a question bank that has just questions on just those topics. So you can go in there and kind of practice just those areas. Now, most of these have something probably like, I don't know, 30 questions or so. Let's see what this one has. Yeah, 33 questions. Some of the other ones are a lot longer. I lost it. I know like the word problem one has something like 103 questions. So plenty of practice here. There's literally thousands of questions, like 1,300 questions. And since we added this question bank in 3 or 4 months ago, probably at the beginning of the summer, it added in a ton more questions. So you really have more than enough practice questions. And, you know, we did a math session tonight, particularly with math. Practice, practice, practice. It's the biggest thing you can do is just do as many of these practice problems as you can, get familiar with it, get used to the timing, all that kind of stuff. So that is the question bank. And then the last part is just going to be flashcards again. And so we're going to have flashcards in 2 different places. I showed you within the actual lesson module, we have flashcards. I think I showed cardiovascular, and we have just the cardiovascular questions. But at the end of the course here is sort of larger sets of flashcards. So if I go into the science flashcards, it's going to give me the entire anatomy and physiology deck, and that is 259 flashcards. I think when we were in the cardiovascular system, it was probably like 30 of these, 260 are cardiovascular, whatever the number was. But you can do a much larger deck and kind of just, you know, go through it that way, or all the biology, life sciences, all the chemistry. So you kind of get the idea how that works. Math, same thing. It's kind of just broken up by the large math topic. So that's everything that's in here. This is, you know, lesson modules, 100 video lessons, 8 practice tests, tons and tons of practice questions in the question bank, flashcards, pretty much everything you guys would need to really study and prepare for your tests. And of course, we have the Facebook study group as an additional place for support. Tons of YouTube videos, so check out the YouTube channel. We're always putting videos up there. Good night, guys. Everybody have a good evening, and we will look to see you tomorrow.